In the previous tutorial, /posts/Python tutorial context managers / we learned about context managers. Now let's take a deep dive into type hints, annotations that make your code safer, more readable, and easier to refactor. Let's break it down. Basic type hints review. You already know these from earlier tutorials. The syntax, parameter, type for inputs, type for the return value. Default values come after the type hint. Greeting, str equals hello. Collection types. Since Python 3.9, you can use built-in collection types directly in type hints. Here is a reference of collection types. Before Python 3.9, you had to import these from typing. Import list, dict, set, tuple. The modern syntax, lowercase, no import, is preferred. Optional and union optional. Value or none. Optional str means string or none. Use it when a function might return nothing. Optional str is equivalent to str none in Python 3.10+. Union, multiple possible types. Union it. Float, str means any of these types. Modern union syntax, Python 3.10+, use instead of union and optional. The syntax is recommended for Python 3.10+. Literal, restrict to specific values. Literal restricts a parameter to specific values. This is like an enum, but simpler. IDEs will auto-complete the valid options and warn if you pass an invalid value. MYPY will also catch errors. Literal is useful for function parameters that accept a fixed set of string values, like configuration options, modes, or status codes. Type alias. Name your types. Create meaningful names for complex types. This makes your code more readable. Instead of seeing dictant, str everywhere, you see usermap, which tells you what the dictionary represents. Type aliases are especially useful for deeply nested types. Annotated. Add metadata to types. Annotated adds metadata to a type hint. Python ignores the metadata, but frameworks like Pydantic and FastAPI use it for validation. In FastAPI, annotated adds validation and documentation automatically. The query, g equals 1, lu equals 100, is metadata that FastAPI uses to validate query parameters and generate API documentation. The type itself, int, is separate from the constraints. Callable. Type hint functions use callable to type functions that take other functions as arguments. The syntax is callable argument underscore types, return underscore type. Callable int takes one int, returns an int, callable str. Int, bool, takes a string, and int, returns a bool. Callable, none, takes nothing, returns nothing. Callable, int, takes anything, returns an int. Type underscore checking. Avoid circular imports. Sometimes you need to import a type only for type hints, not at runtime. This happens when two modules import each other. Use type underscore checking. The type underscore checking constant is false at runtime and true when type checkers, MYPY, analyze the code. Data class with type hints. Type hints work naturally with data classes and provide excellent IDE support. With these hints, your IDE knows the type of every field and method return value. Autocomplete works perfectly. MYPY, static type checking. MYPY is the most popular static type checker for Python. It analyzes your code without running it. MYPY catches errors like these. MYPY configuration. Add MYPY settings to pyproject.toml. Strict mode enables all checks. For existing projects, start without strict mode and enable checks gradually. When to use type hints. Start simple. Add hints to function signatures first. You do not need to annotate every variable. Python and MYPY can infer most local variable types. Gradual typing. Adding hints to existing code. You do not need to add type hints to your entire code base at once. The recommended approach is 1. Start with new code. Add hints to all new functions and classes too. Type hints versus runtime validation. Type hints are checked statically by MYPY. They do not enforce types at runtime. If you need runtime validation, use Pydantic, Tutorial 10, or manual checks. Type hints and Pydantic complement each other. Hints document the interface. Pydantic enforces it at the boundary. Source code. You can find the code for this tutorial on GitHub, kemalcodes/Python tutorial. Tutorial 16. Type hints. Run the examples. Run the tests.